So yes, we are going to see the conceptual execution of doubly linked list, and there are a lot of things that are written on the board. We'll go one by one. Okay, so you will understand it. Whatever we are trying to execute in doubly linked list, as we break down the process, you will understand it. Okay, let's dig down into the topic. The very first thing that we do is to understand what is doubly linked list. Very first, let's understand how the structure of doubly linked list would look like. So this is your doubly linked list, which I have already drawn for you. I'll move this side. Okay, so this is your doubly linked list. This is how the structure would look like. A singly linked list would look something like this. This was our singly linked list, where the first element was our head and the last element would point to null because there was no linking node to it. Now when in doubly linked list, you can see the node looks something like this. 3 parts. Okay, there are 3 parts to it. The middle part is your data. The middle part is data. We already know, we have worked with singly linked list, so we know that we know data part. Now what are these 2 parts? Okay, let's understand this. This part is same like your singly linked list, that is next, and this part is your previous. Okay, this is your node. Earlier your nodes were this, only data and next. Now you have a node which has previous, data and next. That's how your linked list is looking over here, doubly linked list. So how are these nodes connected to each other? Let's try to understand this. This is my first node. My first node has data. Okay, there is next and then there is previous. Now just like your singly linked list, your next is connected to your next node. So this part is connected to next node. What is this previous part? Previous part is connected to the previous node that is there in the list. Now in this case there is nothing previous. This is my first node, so that's why my previous is null. Okay, so previous is null. Data, I am putting the data in it. Next would be the address of the next node that is there in the list. We talk about our second node. So again, as you can see, the middle part is your data. You have next, which is linked to the next node, and you have previous, which is linked to your previous node. Okay, so that is how your linked list is connected. The last node that is there in your linked list, here, whichever is the last node, its next part will have value null because it will have no node to be connected to. Okay, so in doubly linked list, your head previous, your heads previous will be null, and your last element, last node that is there would have its next as null. Okay, so that is your doubly linked list. Let's try to understand how is the structure created, how do we initialize, how we try to insert data. So that is what I have put over here. I have tried to sort it out in the simplest way so that when you write down the program, even executing this will help you to write your program. So let's start with our structure first. So we have already seen the concept of creating that structure for our linked list, singly linked list. Okay, this is how the structure is. One part is data, one part is next. Okay, but in this, what do we have? I have data which is of type integer, I have previous which is of type pointer, and then I have next also as a pointer. Why pointers? Because they are going to store address of the next node. Very similar to your singly linked list. So this becomes my structure. Okay, you have to define structure. Why structures? Earlier also in our singly linked list concept we had seen that we need to tell that this is the structure that has to be created so that I can work on my linked list. There is no data type that will define something like this. Integer, character, float, they tell us that okay, this is the type of data. But in this we have a data type which is a mixture of data which can be integer, character, float, and there are pointers. And in order to have a structure like this, I would require a struct. If I take array, what will happen? Array stores data of same data type. It is collection of data, but data of same data type. Here we don't have same data type. One is integer, it can be character, it can be float, others are pointers. It's a mixture. So to store that kind of data, we have a data structure called as struct, and I use this. Okay, with that, after defining the structure, after telling that okay, this is how I want my node to be, I will initialize my node. And what is initialization of node? We are trying to tell that okay, this node has to be created. Now in this you can see 4 types of nodes that I have created. Okay, struct node star head, then I have struct node pointer 1, okay, struct node pointer 2, struct node pointer 3, and all the values are null. So that means I'm trying to tell that, okay, I need to create node which is going to look like this. I need this structure, and that structure should have previous data next, okay, and there should be 4 of it. I need one head, I need 1, I need 2, I need 3. So this is going to create a structure like this, So in this case, this is your 1. Can you see this 1? This is your 2, and this is your 3. They are nodes. So these are your nodes, and they are given some name, 1, 2, 3. Next is what? I allocate memory. Now we know that, okay, structure is told. I even tell that, okay, these are the nodes that I want. Now I need to actually allocate memory. So in order to allocate memory, we have malloc function, we already know. So I've used the same function for all the 3. 1, 2, 3. What am I doing? 1 is equal to malloc size of struct node. So struct node will give the structure to it, and it will create the structures. Okay, so in this case, what is going to happen? It is going to create such structures, and it will allocate memory to it. Clear? Memory would be allocated to your nodes. This is 1, this is 2, this is 3. 1, 2, and 3. After allocation of memory, what am I trying to do over here? Assigning values. How do I assign values? So I have my structure looks what? Here it is previous, data, and next. That's the structure. So in my data part, I need to put the value. That is what I'm trying to do, assigning data values. So how will I assign? The name of this node is 1. So 1 to data. 1 to data is equal to, I'll put the value. Suppose this is the value. So this value would be put in the center. That is what has happened over here. 2 to data, 2. 3 to data, 3. So I have put the data now. Now the next part that I'm doing is connecting of nodes. Now I need to connect this node so that I see doubly linked list concept. How am I going to connect? Now as we know, our previous, okay, previous for your first node is null. Why? Because there is no node connected to this, right? So previous for your node 1 is null. So if you can see over here, there are 2 lines that are written. The first one says 1 to next is 2. 1, this is your 1, right? This is 1. 2 next is what? It should be this. 1 to next. 1 to next is 2. Not the number 2. Number 2 is the data. 2. 2 is the name of the node. And next what I do? 1 to previous. 1 to previous. Previous is what? Null. Next is what? 2. What do I do? 2 to next. What should be in 2 to next? 3. 2 to next is 3. 2 to previous is 1. Then we have 3. 3 to next will be what? Null. So 3 to next is null. Okay, as you can see over here. And 3 to previous is what? 2. So here as you can see, we have broken down the concept, and I have written down all the steps. This will make your full-fledged programs for you to create your nodes for doubly linked list, right? You will be creating the structure, initialization of the nodes. You can allocate the memory over here, assigning the data values, and you are connecting the nodes. Apart from this, what are the operations that we perform? We perform insertion and we perform deletion of nodes. Okay, similar to your linked list. So go through the concept, very easy. In one go itself, I have put down the whole concept, break it down to understand parts. So the concept is easy.